Hello and welcome back to CST 2120. This lecture covers using MongoDB. So previously explained kind of what MongoDB is and how to get it running. I'm just going to recap a little bit of that in the first part of this lecture. Then I'm going to talk about how we can use MongoDB, covering how we can create databases and collections, how we can insert documents, search for documents, how to back up or dump the database, and then I'm going to go through the sort of database design, the sort of process you need to go through for the proposal stage of coursework 1. Okay, so just to recap, what MongoDB is and how it differs from more standard kind of relational databases. So with relational databases, you have tables and you have relationships between them specified as foreign keys. And we use the structured query language, or SQL, to access and store data. And then they also, as I explained in that lecture on MongoDB, we have these ACID properties, sort of atomicity and so on, that the database management system complies to in order to ensure data consistency. So a relational database will have a bunch of tables, these kind of foreign keys relationships between them, and then a transaction will take the database from one consistent state to another consistent state. And if you try to sort of, you break the kind of foreign key relationships when you're modifying the database, then the transaction will fail and the database will roll back to a consistent state. And SQL uses this kind of, relational databases use this kind of SQL or structured query language to interact and modify with the data and modify it. So, these are some examples. It's quite a complicated language. And so, for example, if we wanted to insert something into the table, here we've got a table here with like a serials table. We'd run an insert table statement that looks a bit like this. And then after running the insert statement and committing it, we'd end up with a serials table that had the new row of data in it. And similarly with select, for example, if you want to retrieve some data from the database, here's our database here. We've got this, Kellogg's cornflakes and so forth. We could run a select statement, possibly specifying some condition. In this case, we're just selecting everything. And then we get the results back, from the database. Yeah, in fact, we want, in this case, just the name of all of the rows of the table. So this is kind of an SQL database or relational database. MongoDB is a NoSQL database, which works a little bit differently. Yeah, so if you know relational databases, you need to sort of, not just blindly try and apply that knowledge to MongoDB. Yeah. So MongoDB, as I explained in the previous lecture, it stores JSON documents, but instead of having this structured query language, we store and retrieve data from the database using functions. Yeah, so it's like a find function, an insert function, and I'm going to go through these functions in a lot more detail when I talk about using Node with MongoDB. But you can, if you want to test them out, you can also run these functions on the command line using the command line client. I'm not going to cover that here in this lecture. But if you want to practice, test to see if a particular function's working, just run it on the command line client. Yeah. So in addition to these functions, we have this JSON-based query language. Remember, SQL relational databases have the structured query language. MongoDB has a JSON-based query language. Yeah. And it's quite a powerful language that does a similar job. It identifies documents that we want to retrieve, but we also use the JSON-based query language to specify the documents we might want to delete or modify or update and so on and so forth. Yeah. So the searching, I'm going to cover searching in this lecture, but the kind of the JSON-based query language that I'm using for searching is exactly the same language we'd use for modifying and deleting and so on and so forth. Yeah. So once you've learned it for one application, it's generalizable, to other functions. So as you might remember, MongoDB is all based on JSON documents. Here's an example. You have the ID, which is kind of generated by MongoDB, and then a bunch of key value pairs, just like a JavaScript object or JSON document. Yeah. And then we have collections, which is you can think of as folders that hold one or more documents. And we have a database that holds one or more collections. And again, you can think of it as a folder. Database is like a folder that holds folders with all the collections, and each collection folder holds all the documents. This doesn't exactly work like that, but that's a good way of thinking about it. So once we started up with MongoDB, we've got Compass running because I'm going to be using Compass in this example. What we want to do is start by creating a database and some collections in that database. And there's lots of different ways to do this. Yeah, we could use the graphical interface called Compass, developed and provided by MongoDB. If you remember from the previous lecture, we also had the kind of Atlas web interface that we could use to interact with the kind of cloud database. There's also the command line client, and we could also write code that would do the same thing. Yeah. In this case, for this lecture, I just want to introduce these ideas. I'm going to use Compass to create the database and the collections. If you want to use a different tool, that's completely fine. It really doesn't matter. And in general, when I'm working with databases, relational or NoSQL, I tend to create the databases and the collections or tables just using graphical tools. You know, there's graphical tools for like MySQL, for example, MySQL Workbench. And in the case of MongoDB, we have Compass. So for stuff like creating database and collections, it really doesn't make any, you can create them with code or, but you can write SQL that will create databases and tables, but it's often easier just using a graphical tool because you tend to create a database and the collections or tables once. And then it's the code will then be used to kind of modify the data in that database. Yeah. So here's the Compass GUI, which I'll be using for most of the demonstrations in this lecture. So now I'll show you how we can use this GUI. So what I've got going here, this is all based on the portable version of MongoDB. But if you remember from the previous lecture, we can connect Compass either to the portable version, portable or local server in this case, or we can connect it to the cloud server. It'll work with both of them pretty fluidly, yeah? So in this case, just for simplicity, I've connected up to my local. I've got the portable version of MongoDB running here on my computer, and then I'm connecting Compass to that local portable version. So to create a database, really easy. We just press plus. We can create database and collection together. So I'm going to call this CST 2120. Call the collection users, and then I just click on create database, and bingo, here we go. Right, here's my database, and here's my users collection. As you can see, it even represents it as a folder structure there. So that didn't take long. Okay, so like I said, no point really in learning how to insert that stuff, create that stuff, using code, yeah? Just click couple of clicks and there it is, yeah? So next I'm going to cover the insertion of documents into the database. Now, usually documents are added and edited by code, yeah? So for example, in your coursework 2, the user is going to enter some registration details and click submit. The front-end JavaScript is going to extract the data just like you did in coursework 1, but in this case, it's going to send it to the server. And then on the server side, the back-end JavaScript is going to receive that data, and it's going to insert the document with the database containing those new user details. Yeah. So, in most cases, when you work building web applications, it's the code is going to be inserting documents, modifying documents, and so on and so forth. The main big exception to this, in the context of this coursework, is when you're doing your proposal, I'm asking you to design a sort of database, bunch of collections, and the typical documents in each collection. In that case, you'll be inserting documents manually. And you also insert documents manually if you just want to test something or, build some example data just to play around with your web service. Yeah. So later, when I talk about Node.js and MongoDB, I'll show you how you can insert and modify documents using JavaScript. In this case, just to get you started, so I can show you search and all the rest of it, I'm going to insert documents using Compass. Yeah? And so use this approach to create example documents for your proposal or for testing your web service and all this kind of stuff. Right, so I'm going to put a few documents in here because I'll need them later for searching, and I'll try and add some that, make some kind of sense. So let's just put a document, so insert document, right? So on Compass, we just add data, and we could import a JSON file, but we're not going to bother. So it's really easy, we just insert document. Now just remember, so don't touch the IDs. They're generated and managed by MongoDB. Your life will be more complicated if you try and mess with the IDs. So leave the automatic generated IDs. And then we're going to create a few documents here with some example data, just to show you some of the other features such as searching and so on and so forth. Yeah. So create, give some names. Jane Jones. I think just name and age will do for this. Yeah. And then age. So remember, it's all JSON. Yeah. So age is a number. So 22 or something. Yeah. So we create one document, Jane Jones. Obviously, the users for your web application have more data in them, and we'll talk about that in a little bit, yeah? So we've got Jane Jones. What do we got? So let's call Jane. I need to support a few different kinds of searches. So that was Jane Jones, wasn't it? John Jones. And keep the same age. Age 22. I can just press return. No, I can't press return. Okay, so got Jane Jones, John Jones, at a different name maybe. So John's name, John Smith. We'll make this one, 23 or something, yeah. Age 23. Maybe just, maybe another one, I don't know, Anne Smith or something, right? I may have to add a couple later to demonstrate functionality, but I think this will do for the moment. Anne Smith, and we'll make her age, let's make her 24, yeah, just for illustrative purposes, yeah? Okay, so as you can see, very easy, in a couple of less than a minute, I can create my database and create my collections, and I can create example documents in each in my collections, yeah? So these are my bunch of examples I'm going to use when I demonstrate the search functionality. So now we come to the searching for documents, and this is the kind of the heart of using MongoDB, really, and that's why I'm going to spend some time now talking about the different kind of searches, because we use this search to identify, obviously to retrieve data from the database, that's really important, but we also use the search to this same query method to pick out documents for deletion or pick up documents for modification and so on and so forth, yeah? So to use MongoDB, you absolutely have to understand, how to run searches on the database, yeah? So it's, very rigorous MongoDB. It has JSON-based documents, but it also has JSON-based search. So everything is JSON in MongoDB, yeah? And we have several different kinds of search that we use. Yeah, we've got a simple search where we just want to look for key value combinations, and I'll go through each of these in more detail. We can also search using and or, look for things that match multiple things anded together or ored together. And we can do, the sort of standard stuff you do in most databases, where we can look for things that have a field that's greater than a certain value, less than equal to, and so on and so forth. Yeah, that's these keywords here, LT, LTE, and so forth. And then we can also do index searching, where MongoDB will chop up a long text field into individual words, strip out words like the and so on and so forth, and run the search against those split up kind of text, yeah? And I'll go through each of these in detail and hopefully make each of them clear, yeah? So simple search is really easy, right? We just specify a key value pair, and then MongoDB looks in the database, do all the documents, it returns the documents that have that key value pair. So the key has to match and the value has to match, and then it'll return, all the documents that match that, yeah? So for example, if I search for name Tony, it returns all documents with the name field set to Tony. So let's do that first. So in Compass, we can test searches like here at the top just by typing them in, yeah? And whereas, in some contexts, we have to have JSON-based searches, Compass will let me get away with just skipping the quotation marks. So I'm going to skip the quotation marks here, right? So for example, if I wanted all the fields that have name, and I have to use quotes around strings, yeah? And Smith, yeah? Maybe you can press return here, yeah? Then it gives me all with Anne Smith. Or if we want, John Jones, there's got going John Jones. Or if I wanted, age, in this case, 22, then it's giving me all the fields, all the records, all the documents where age is set to 22, yeah? But note, this is a very rigid search, yeah? So if I do name, John Jones, for example, yeah, there's no results at all because it has to be an exact match. And this is why we need something like the index search, which I'm going to cover later, yeah? So simple search is just looking for key value pairs that exactly match the key value pairs in the documents. Now we can have more complicated things. Sometimes we want to look for records that match one property and they match another property, or they match, or they match one property or they match another property. Yeah? And that's where these and or keywords come in. Yeah? And to do this, as I said, it's all very rigorous JSON. We specify the operation, in this case and they all these keywords in MongoDB's queries have like this dollar before the word. Yeah. So probably a good idea to avoid dollars in the names of stuff when you're working with MongoDB. So here we have the keyword and or, and it points to an array of key value pairs. So remember, the simple search is just looking for a single key value pair. Here we have an array of possible key value pairs and the rule that combines them together, yeah? So if we say and apply it to these two key value pairs here, then this will look for records whose name is John and whose age is 22, yeah? Or it'll look for records whose age is 22 or the age is 23, with all of these or possibilities put in an array after, you know, as the value of the or key, so to speak, yeah? Okay, so the array is the sort of options, so to speak, and the key here is how these options are combined together, yeah? So it's always easy with examples, this stuff, yeah? So let's do this, yeah? So if we have and, for example, now let's just get all my records, actually, just do empty, see all the records, yeah? So for example, we might look for sort of documents or users in this case whose age is 22 or age 24, for example, yeah? So in this case, we could do an and then that points to another JSON document. And so in this case, it's pointing to an array of JSON documents. And in this case, sorry, I'm not doing so well here. Get rid of that and that. Okay, so that's right. Yep. So it's an array of key value pairs. So age 22 and second one here, age 24, for example. Yep. So in that case, we're expecting, let's finish the array. Yep, that's right. So an array of objects there. So I'm expecting it to return Jane Jones, John Jones, and Anne Smith. Yeah. And it hasn't found anything because, oh, yeah, that's why it hasn't found anything. Let's just start with or, actually, because there are none that have age 22 and age 24, right? So if I do or, then we've got Jane Jones, John Jones, and Anne Smith, okay? Because it's looking for ones where the age is 22 or the age is 24, yeah? So let's find a better query for and, because that wasn't such a good one. So we could look, if we wanted to, let's just get rid of this for a sec, yeah, just so we can see the whole set of records. So for example, if we wanted to get someone whose name was John Jones and whose age is 22, like applying two queries instead of just, so if we just look for 22, we're going to get Jane Jones and John Jones. But if we look for someone whose name equals that and whose name equals that, then we can and them together and we should just get John Jones, yeah? So for example, if we do and, same syntax, right? Array, and so we can do age, slightly artificial example, I appreciate that. And name, because John Jones is unique anyway, right? So it's somewhat pointless, right? One might argue, but it's an example, right? John Jones, yeah. If we had two John Joneses with different ages, then then this would be a way to pick them out, yeah. Okay, so we do find there, so we get John Jones, and let's just do that actually, yeah. So let's just something to make it a bit more realistic. Okay, so we have name. Well, you'll see me seeing a little bit of this because to show things better, yeah. So, and let's make this one age 27 or something, yeah. So if we insert that there, and then we run this query now, so if we just do age John Jones 22, but if we're just looking for, we can just provide one here, even though it's a bit pointless. If we do, we've got two John Joneses, two people with the same name, one's age 22 and one's age 27, but if we just want to get the one that's aged, can I do that? Yep, the one that's aged 22, then I can AND them together, so look for ones that are John Jones and 22, yeah? And I've already done the OR, right? So in this case, if I put an OR back in here, it'll get all the records whose name is John Jones or whose age is 22, yeah? So in this case, we're also getting Jane Jones, who has the age set to 22, yeah? Okay, so that's AND and OR, which are pretty handy under some circumstances. Not really this one, but some. Then we have these operators, right? So again, with SQL, we're often looking for values where you're looking for greater than, equals, not equals, and so on and so forth. Yeah. So MongoDB supports that. We've obviously covered equals already, but we've got a bunch of like greater than and equal that, greater than, less than equal to, not equal to, and so on and so forth. Yeah. Very useful operators for any kind of query language. Yeah. And MongoDB handles these operators using this this dollar notation and these keywords like LT, LTE, GT, GTE, and NE. Yeah? So it's quite easy to understand, right? LT means less than, LTE means less than and equal to, NE means not equal, and so on and so forth. Yeah. And as you might be guessing by now, it's all based on JSON. So here I have age, the key, and then there's a JSON object here in which the greater than, so this is the key that we're searching on, like age, and instead of just saying age equal 22, which age 22, that'd be like the simple search I covered earlier, here it's age is pointing to here, where it means that age is greater than or equal to 22, yeah, or age is not equal to 22, yeah. So the sort of second object here is specifying a greater than, less than, and so equal to relationship, which is applied to this particular field, yeah. Again, we can do a sort of nice little demo here. I've kind of covered and already, but I'm going to let's cover some of these, yeah? So let's get the full data set back. An empty query, empty brackets just means it returns everything, yeah? So let's look for ones for all the records that are not equal to 27, for example, yeah? So let's stick to age for the moment, yeah? Age, and then we put a second set of curly braces, and then we use this keyword here, not equal to 27, for example, yeah? And so obviously, in this case, the only one that is equal to 27 is excluded, and all the ones that are not equal to 27 are excluded, yeah? And I think we got some that are 23, so for example, if we wanted age greater GTE, for example, to 23, for example, then it gives all the ones that are greater to than equal to 23. And if we want to do less than equal to, then less than equal to 23. And I think, have we got, I don't know, but it may possibly be able to do sort of alphabetical, but I'm not going to try that here. Mainly you'd use these kind of things on numbers, yeah, rather than using one like alphabetical stuff. So I think it's pretty easy, right? That's, you know, same, you know, I'm not going to go into much more detail about that. I think it should be pretty clear, yeah? Okay, the next kind of querying is kind of a bit more interesting in a way. So if you think of a book, right? So in order to be able to find things quickly in a book, you have a bunch of kind of keywords in the index, and you look up the keyword in the index, and it takes you to place in the book. Yeah, so that's what indexing in a book means, which I'm sure you all understand very well. But in database terms, one can or MongoDB database terms at least, we can index particular fields, and in some databases that'll just sort of optimize queries on that or enable different types of queries on the database. Yeah, and in the case of a kind of text index on MongoDB, what it'll do is you provide a text field, like a long text field of some kind. And then if you index it, MongoDB will slice up that text field with to get all the separate words using space operators, something like that, yeah? Looking for all the spaces and then chopping out all the different words. It throw away all common words like the and so on, and keep the ones that remain. And then it'll let you search against all of the individual words that are in a particular, the value of a particular key, yeah? And so that means this is very useful in some circumstances, right? When I showed you the simple search, we always have to look for an exact match of a field, yeah? But in many cases, we'll have a document that has, for example, a bunch of keywords separated by commas, or we might have a long description of a product, yeah? And so in that case, you might want to search within the document for specific matches, just like you'd search inside a Word document, yeah? And so to search within a document, we can do that in MongoDB using an index search, yeah? So what we have to do is specify the name and the value of the index. So the name is like a field in your document that you're going to index, and the value is the type of index, and in this case I'm just covering text indexes, yeah? And then once you've done that, we can search within the fields, and so if we had a bunch of keywords, we could search within the keywords or in the description. So for example, when you're implementing this on your social networking website, you might have like a blogging website, for example, and you might want to search inside the blogs for particular topics. Yeah, that'd be a sort of very typical usage of this, yeah? And again, as you might expect, there's lots of different ways in which we can create the index. We can use the command line client. We've got the Atlas web interface, and also Compass. So I'm just going to use Compass here because it's the tool I'm using to illustrate, and you know, it's a very easy tool to use, as you can see, yeah? And once we've got our index, well, let's do this. I'll go in steps. Actually, I was going to do this all at once, but I think to be clear, let's do it step by step. So here's my collection here. To create the index, I just go into the indexes tab, so to speak, and click create index, really, really easy. Pick the field I want to do. In this case, I want to index the name. And then we select type, and let's not get into the fancy types. Let's focus on text, and then we just click on create index. Yeah, and there we go, bang. We now have our index. And you can see that if you're not sure if you created one, you can always go back to the indexes tab and see the list of indexes and delete indexes and so on and so forth. Yeah. Now, once we've got our index, we can search within the text stored with the key specified in the index. Yeah. And we use the text keyword to identify which index we want to search on. And then we search specifies which term that we're going to search on. Yeah. So for example, here, if I've got text, that's the type of index I'm using. And then the search term here is John. Yeah. So to look for remember it was indexed on name. It'll look for all the names that have John somewhere inside them. Yeah. It doesn't have to be an exact match anymore. It'll look for a partial match with the complete name. Yeah. So in this case, it's returning all users whose name include the words John. Yeah, it's not going to split up the words themselves. It won't look for partial matches within the words, but it will look for its matches, on individual words within a long piece of text. Yeah. So text search John. I just remember this because I tend to forget this every time. Okay, so now we can run a search on this. So let's do. So in this case, we'll do a search. So remember, we specify the type of index here, text. Then we specify our search term. Okay. And in this case, let's look for all of the users who have Jones, in their name. Yeah, for example. Yeah. Slightly artificial example, I know. Okay. So that's all the ones with Jones. But remember, it won't do partial matches on words. So it's done that, actually. I wasn't expecting that. But yeah, it's done that quite well, actually. So I guess if we do JO, if that's working so well, it hasn't found anything. Yeah, so it's kind of got a limited ability to look within the words. Yeah. So we go back to Jones. Now, if I look for example, Jane, I think there's only one Jane. There's only return one Jane. And that's about it. And then really, and John obviously returns all the Johns and so on and so forth. Yeah. So we no longer have to look for an exact match for the entire field. We can look for matches on individual words within these things. And this is, as I said, slightly artificial. But once we come to kind of keywords and long text descriptions, it's extremely useful. Yeah. All right, so that's my sort of introduction to how to query with MongoDB. And if you practice it a bit, you'll get the hang of it. It's so simple to use with Compass. And then obviously, when it comes to your real web application, you're going to do those exact same queries, just using code. And you'll probably have to put the full quotations in with code in a way that you don't have to with Compass, yeah? So now let's move on to a couple of other topics that I need to cover, one of which is backing up or dumping databases, yeah? So computers fail all the time, right? And databases fail all the time, right? So servers fail, server rooms get flooded or burned to the ground, people lose hard drives and so on and so forth. Yeah, data gets lost, yeah? And these days we have this kind of constant threat of ransomware, so someone hacks into your network and encrypts your entire database, so you can't access it unless you pay them money to decrypt it, yeah? So if you want to protect yourself against these kinds of attacks and losses and failures, you've got to back up your database regularly and put it in a separate physically secure location. Yeah, and that definitely applies if you're running your own server, in your own kind of server room. But it probably also applies if you're running even a cloud database. Yeah, because yes, currently the MongoDB Cloud Atlas is running on AWS, right? AWS is pretty reliable, right? But it's not 100% reliable. And at some point, it'll probably fail and a whole bunch of web systems all over the world will go down. There's a glitch in AWS, I know a few months ago, last year, I can't remember exactly. And, a load of websites, failed because they're all depending on AWS. Yeah. So AWS is good, but it's not 100% bulletproof. Yeah. So even if I was running my database on AWS, as some of you are, I would still download that database regularly, maybe encrypt it, and put it in a different physical location. In the context of coursework 2, it's also, you need to be able to export documents and also dump the entire database or export all the documents in the database, because for the proposal stage, you need to provide examples of documents from your database. And in the final submission, you need to do a dump of your complete database, as it exists, at the time of finishing your project. Yeah. So exporting is an important tool, important skill. You need to know how to do it, and so that's why it's covered here. Yeah. So in the design, I'm expecting you to list the collections and give examples of documents within each collection. Yeah. Now you could just code up those documents manually, but I strongly recommend instead you create them in Compass or a similar tool, and then just export them, and then you've got them there, and they're all perfect, and you've already got a good start for your project. Yeah. And for the final submission, you've got to do a complete dump of your entire database. So dumping and exporting a database is kind of the same thing. A dump just means taking everything in the database and putting it into a text file of some kind. Yeah. So there's different ways in which you can back up your MongoDB database. Firstly, it has some very nice command line tools. So in a real production environment, we'd have a sort of cron job or background process that basically dumped the database and used rsync or something like that to put it into a different location, physical location. Yeah. So we just automate that using the command line tools, which is why it has those command line tools. Yeah. In this lecture, I'll show you both. And then there's also Compass, which lets you export individual documents within a collection. Yeah, individual collections. Yeah, not just individual documents, but the entire collection. Yeah, so I'll show you both. But for your projects, it's fine if you just use Compass. I don't mind at all. Yeah. So command line tools are nice. Yeah. So in the portable version of MongoDB, I put them in the bin directory. There's also a MongoDB website, so if you're on a Mac, you can download them from there. Yeah. I'm going to show you again with the portable version of MongoDB. You need to change the command line parameters a little bit if you're using the Atlas server. Yeah. If you're using Atlas and with the local command line tools, you'll need to specify the server and username, password, and stuff. Here I'm just using them with like root and no password, so I can get away with less of these parameters. Yeah, but we can help you with that in the labs if you want to use command line tools to dump an Atlas database. Yeah. So two tools I'm going to cover here. I'm not going to cover restore because but it's the inverse of MongoDump. So MongoDump is a nice tool. You just run it, no parameters, and it'll dump the entire database to a folder in the bin in the same directory as it, unless you specify otherwise. The files in there are BSON files, and then if you want to reload the database back up, you can use Mongo Restore, which will read those BSON files and put them and recreate the database as at the time in the same state it was when you dumped it. Yeah, that's what these two tools do, and they're pretty good and easy to use. Yeah. And then Mongo Export and Import are more kind of collection focused. So Export will let you export a particular collection as a JSON file, JSON document, and then Mongo Import, I presume, I never tried it, will reverse it and take a JSON document and load it up into a collection. Yeah. So MongoDump's the one I've used quite a lot. Yeah, it exports the entire database as BSON files, and BSON is just binary JSON. So if you open it up in a text editor, and I'll show you this, you can see that some parts are going to binary and you can't read them, and other parts just ordinary text. Yeah, but what's nice about MongoDump is you just get this nice clean dump folder, and then you can just run Mongo Restore and just put the database back into that state. Yeah, so it's pretty convenient, I have to say. And then Mongo Export, you have to provide some command line options to specify the database, the collection, and the output file, and then it'll take that collection in that database and store it as a JSON in the JSON file that you specify. Yeah. Okay, so let's do a couple of demos just to show you it working. So let's start with start with the files. Yeah, so this is so in portable MongoDB or whatever, there's MongoDB, and then there's bin, and then I've put these files there for you, right? I'm not sure what BSON dump does. So we have MongoDump, that's what I'm going to show you, and we got Mongo Export, and Mongo Restore is the inverse of MongoDump, and that's why I'm guessing that Mongo Import is the inverse of Mongo Export. Yeah. So you run these tools in command line, and you can double click it, but I'll show you on the command line. So if we just do MongoDump, for example, run MongoDump. It tells you, if it's worked, it tells you done dumping, so on and so forth. You go back to the bin directory. You see here, now we have a dump folder here. It's dumped admin, which we don't really care about, but this is our particular, the collection we wanted to, our collection, the one we created. And if we open that up if we manage to open that up in Notepad++, we can see here, this is the BSON file, binary JSON, so we can actually see most of it. And this is when I say that the dump has to be mostly readable in a text editor. This won't really do for the proposal, but it's fine for the final submission. This kind of a dump that looks like this. Yeah, we can see that it's got the data in there, and we could restore the database to its previous state by loading this up into it. Yeah. So that's MongoDump. Okay, and then the other one is I've done it before, so I'm going to just save myself some typing here. So this is Mongo export, yeah. So here we specify the database /d, which is CST 2120, /c is the collection users, so D and C, pretty easy, right? And /o means output. So if you look here in the folder, we've go up a directory 2 and to bin directory. There's nothing in that directory at the moment. Obviously, you could specify like all the folder structure and stuff, but I'm not going to bother. So this should be output a file called users.json with everything that's inside my CST 2120 users collection. Yeah. And yeah, looks like it's probably worked. And so go now. Here's my users.json. So again, if I open it up on a text editor, you can see here now I've got all the documents inside the users collection are here. Yeah. Okay, so again, this is, for your purposes of your proposal and even for your final backup, as long as you do this for each of your collections, this is completely fine, yeah? You can also do the same thing in Compass. I think Compass is probably using Mongo export behind the scenes, yeah? So we select the collection we want to export. We export the collection, and then we choose the JSON file type, choose where we want to go. And with all of these exports and dumps, what you absolutely must do is check that the export has worked, yeah? So many times I see in submissions, students have kind of thought they did a dump. This happens particularly with the relational databases. They send a file in and the file's empty or it's missing the data or some other problem with it, yeah? So whenever you're doing this for anything really, you always need to have a look inside and make sure that what you think has been dumped has actually been dumped, yeah? That's absolutely crucial, yeah? And that's why I keep opening it up to show you, but I would have kind of opened it up myself when I was doing it. Yeah. So let's just let's run our sort of general query. So here we've got 5 documents, right? And we want to export all 5. So let's say we select. In this case, I haven't got any other collections, but I'm selecting the users collection here. And I do collection, export collection. Select the JSON type. Yeah, that's what I want you to export it. I don't want it in CSV format, thanks. And then we click on export. We choose where we want to put it. It'll do week 13, yeah, just need to remember that. And then it's export completed. And then if we go here where I think it's exported, if I go up, it's 2120, week 13, I think it was, wasn't it? Yeah, there we go, yeah. Probably not a very good location. Then again, open it up. And here we've got very nice, it's actually a nicer export in some ways because it's put it in array structure rather than like JSON lines, it looks like the previous one. Here we have each of the documents in my collection very nicely exported and formatted, yeah? So really good, right? I've checked it now, I know that that's exported my users collection, yeah? Okay, so final thing I want to cover in this lecture is a little bit about MongoDB database design, yeah? Because I'm asking you to use MongoDB to store and retrieve data. And in the proposal, I'm asking you to produce a design for your MongoDB database. Yeah, so it's got various purposes behind this, right? I want you to understand how MongoDB works because otherwise it's going to go badly for this piece of coursework, yeah? And I want you to think about your project and think about how you're going to, what data you need to store and how you're going to store it, yeah? And that's why I want you, for the proposal stage, to produce a design, yeah? So it's not a design in the sense of traditional relational database design. In this case, the design is more like, what am I going to call the database? What collections am I going to have? And what kind of data is going to be stored in the documents, yeah? Now, if you come up with a bad design, that's fine. The whole purpose of the proposal is you come up with a design, we give you feedback about it. We won't lose any marks for a bad design, but you will lose marks if you don't think about it carefully enough and miss like really important data in your design. Yeah, so if you have a registration system but no passwords stored in the user's documents, then it's a bad design. Yeah, it's a design that will lose marks. Yeah. So you need to come up with a sensible design that captures all the data that's going to be required by your social networking website. So this is the, thing you need to do. I forgot to cover up obviously if you're watching this in 2025, the deadline obviously has changed. So these are the marks of the database design, yeah? Suppose I want to show you what I mean. I'm going to talk about a simple design. It's just a sort of very basic, bare bones idea. You're going to need something probably a bit different for your own social networking websites, but just to give you an idea. So suppose I'm building a simple blogging website. Yeah, I've got registration login. I've got some blogs I need to store that were created by the users, and users can follow other users. So that's the sort of functionality I want at the front end. And to support that functionality, I could create 3 collections to hold data for the project. One for the users, one for the blogs, and one for who's following who. So this is my sort of very sketchy initial design, yeah? And these are the example documents that I'd be submitting if I was, writing a proposal for this project, yeah? So you can see here, each of the users has a username, a name, and a password, and an age, just pointless bits of detail there, really. And the sort of crucial things to support registration, obviously, are the username and the password, yeah? So I'm assuming here the key assumption behind this design is that the username will be unique. I could use the object IDs, but they're a bit fiddly, and I could have used emails instead of usernames. But I need some unique property associated with each user, which I'm going to use later. Yeah. So username, password, registration, and this username here I'm assuming to be unique for each user, and I can enforce that at the time of registration. And then the blogs documents, I can then use that username to know who wrote which blog. Yeah, I could use the object ID of the users, but somehow this feels more intuitive, so I'm going to go with that. Yeah. So the username here is used here to indicate which person wrote which blog. Yeah. So Jane wrote, the story of my life, it was great. And Tony wrote, my first amazing blog. Yeah. And so associated with that username is the data of the blog, in this case, text and a date. Yeah. So I think this will work pretty well. Yeah. And finally, there's a problem of following, right? So again, I can use this unique username. So here, the username's here. And then the following is just an array of all the other usernames of people who are following me. Yeah. So using this design, and suppose I wanted to show all the people who are following, or suppose I want to show, so wait a minute, this is Bob who's following, so it's the other way around. Bob is following Tony, Jane, Sonia, right, for example. So if I wanted to show Bob all the blogs of the people he's following, I'd first go to this collection, and find Bob 1, 2, 3, and get that array of Tony, Jane, and Sonia. And then I'd go to this blogs documents and search up all of the users, like Tony, Sonia, and so on and so forth, and get all their blogs, and then I could display them to Bob. Just an example, right? You need to think about your idea, how your social networking website's going to work, and come up with a better design, yeah? So you're doing recipes, obviously it's going to look a bit different from this, yeah? And when you're doing your proposal, please give me some kind of name for your database, whatever you like, really. Really important, though, you must list all the collections and include examples of documents from each collection. You can dump these documents, preferably not in BSON, but in JSON format. You can export them, as I just showed you. Or if you want to write them manually, that's fine, but you'll find it better and easier if you start to engage with MongoDB, get it running, and then create some example documents and then export them. That's definitely the best way to do this particular part of the project, yeah? And so in this case, my name of this is the follows collection. This is an example of follows, example of blogs, and so on and so forth. Yeah, and you should look a bit like this, your proposal. Yeah, and these documents can be in a separate folder, zipped up with your proposal, or if you like, you can take screenshots or paste them into your proposal. Either is fine. Yeah. Okay, that's that. So yeah, as explained, we're using these. You need to come up with a design that captures all the data required by your project. Yeah, if it's not a good design or it's got some flaws, that's okay. You won't lose marks, and we'll use the free proposal to give you feedback about that. Yeah, it's all about helping you to improve what you're doing, and that's what the proposal is about. But if you don't think about it and just come up with copy a design off the internet that's nothing to do with the social networking website, then obviously we'll give you no marks because you haven't thought about it, and tried your best to come up with a good design. Yeah. And I get asked this question a lot, so you can reuse material from the proposal in the final project submission. I anticipate that you'll change your design, and there is marks for dumping your final design. So obviously your final dump, which you need to do for your final submission, must match. It must be the dump of the right database that you're using with your actual code. Yeah. Okay. So this lecture I've shown you how to create MongoDB databases, collections, and documents. It's like example documents. As I said, real documents being inserted with code. We use search to retrieve documents, but also this kind of query language of MongoDB, this JSON-based query language, is used to specify the documents you want to delete or update and so on and so forth. Yeah. I've shown you how you can use simple search, these kind of keywords like and, greater than, equal, and so on and so forth to do searching. And also you can index fields, complex text fields, so you can search within that text. Yeah. You need to create a MongoDB database design for your Coursework 2 proposal, and you need to export your database for your final submission, and that's why I've shown you how to export individual collections as well as dumping the entire database. And that's it.